We're going to continue our look at factoring expressions that are beyond the basics. So let's look at the sum and difference of cubes. Let me refresh your memory on what that looks like if we're going to factor a cubed plus b cubed. Remember, it will factor into two factors. One is a binomial and the other is a trinomial. And the binomial is what you get when you just remove those cubes. So I will have a plus b. And in our trinomial, I just use the pattern that I have practiced. With respect to this binomial that is a plus b, I take the first term and square it. And I take the last term and square it. And that will give me two terms of my trinomial. And in the middle, I take the opposite of their product. So I have a times b, change the sign, that makes it negative ab. And that's our factorization for the sum of cubes. Remember that we also have an acronym that will help us remember the signs, and that acronym is SOAP, because there are three signs we really need to focus on when we're factoring the sum of two cubes, and they are here, here, and here. And the first sign that you write is always the same as the original. So we had a plus in the binomial, and we had the sum of two cubes. Now the next sign that we write is the opposite of that. And you see right here, in the second place, we have a minus. Here was the first place that was a plus. And the third sign that we write right here is always positive. And that acronym helps us remember those signs. And that acronym works whether you have the sum or difference of two cubes. So let's write the factorization for the difference of two cubes. A cubed minus b cubed factors into a binomial and a trinomial. Let me set up my parentheses. And now I will use that acronym to put the signs in first. I have the same sign, so it was an a cubed minus b cubed, so I have a minus here. Then the opposite of that, and then always positive. So I've taken care of the signs, and I don't need to worry about those anymore. So in the binomial, I just rip off the cubes, and I have a and a b, so the binomial is a minus b. So my first term of the trinomial is the a squared. The middle term will be a times b, and the last term will be b squared. And we have it factored. So now let's look at some that are beyond the basic problems. But we need to be able to identify when we have the sum or difference of two cubes. So let's write our list of what perfect cubes look like, so that we know what we're looking for. If we look at numeric perfect cubes, they look like this. 1 cubed, which is 1. 2 cubed, which is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125, and so on. But we also have algebraic expressions that are perfect cubes, like m cubed, or a cubed, or x squared cubed, which we know is x to the 6th, or x to the 3rd cubed, which we know equals x to the 9th, or x to the 4th cubed, which is equal to x to the 12th, or x to the 10th cubed, which is equal to x to the 30th. So look at those exponents. How will we identify that we have a perfect cube when we're looking at an expression with exponents? Notice these exponents are all multiples of 3. So if we have an expression that has a multiple of 3 as an exponent, we know it's a perfect cube. For example, if we have x to the 18th, we know that that is something cubed, and we can figure out that it must have been x to the 6th cubed. So now that we've looked at perfect cubes and we have recalled what the pattern is when you're factoring the difference of cubes, let's practice some problems. So the directions will be factor completely, and our first example will look like this. X to the 15th plus 1,000. Now, 15 is a multiple of 3, so we know we have a perfect cube. So let's write it as x to the 5th cubed. And let's see, 1,000 is 10 cubed. So now those perfect cubes are looking at me clearly, and I know what to write when I'm factoring into the binomial and the trinomial. Let's see, I'll put the signs in first. The same sign, opposite sign, always positive. And back to the binomial, I just rip off the cubes from the previous line, and I'm left with x to the 5th plus 10. And now my first term of the binomial is this x to the 5th squared. The middle, I take the product of 10 and x to the 5th. And in the last term of the trinomial, I take the 10 and square it. So that gives me 100. If you peek at this trinomial, you will see that it is prime. So I have completed the problem. We don't need to continue further. Let's do another one. Here's the example. It will be x to the 13th minus x to the 7th, y to the 3rd. As we look at this one initially, we don't see the difference of 2 cubes, but I do see that there's a common factor, and of course that's what we always take care of first. Do you see it right here? We have factors of x in each of those 2 terms. So let's take out that x to the 7th that they have in common, and I'll be left with x to the 6th minus y to the 3rd. And now we have the difference of 2 cubes. Let's write it so that those cubes are very obvious. So I have x to the 7th times x to the 2nd cubed minus y cubed. And now I'm ready to factor that difference of 2 cubes. So I'm just going to bring down my x to the 7th. I have a binomial and a trinomial. I'll fill in the signs. I have the same sign, opposite sign, always positive. My binomial will be what I get when I just remove the cubes, so I will have an x squared. Oops. I will have an x squared and a y. So my binomial is x squared minus y, and then I just practice the pattern or use the pattern I have practiced. So I square the first term and I have x to the 4th. I take their product in the middle, that's x squared y, and the last term will be y squared. And again, that trinomial is prime, so I don't need to continue. So this one is finished as well. Let's look at this next expression that we'll factor. The example would be x to the 7th minus 125, x to the negative 11th. And we see that we have a common factor. The exponents on the x are a 7 and a negative 11. So the common factor is x to the negative 11. Remember, you look for the smallest exponent. So let's take out that x to the negative 11. And then I'll be left with x to the 18th. Remember, to get this 18, you take the 7 and subtract negative 11. And then we subtract 125. We recognize that x to the 18th is a perfect cube because the exponent is a multiple of 3. So let's take a line to rewrite it so it's very obvious what's being cubed. We have an x to the 6th being cubed. And let's see, we have a 5 being cubed. That's a little bit sloppy. I'm going to rewrite that exponent of 6. There we go. So let's continue. We bring down the x to the negative 11th. We have a binomial and a trinomial. I'll just fill in the signs. Same sign, opposite sign, always positive. And our binomial, are you getting more comfortable with that pattern? We'll just remove the cubes and we're left with x to the 6th minus 5 for our binomial. And then for our trinomial, we have x to the 6th squared. In the middle, we take the product of 5 and x to the 6th. And our last term will be 5 squared. And again, this trinomial is prime. The binomial is prime. And we can't do anything else with x to the negative 11th. Well, we could do something. We could write it as 1 over x to the 11th, but that's unnecessary. We could leave the answer just like this. Let's do another one. Let's use some exponents that aren't integers. How about this for our example? M to the 8/3 plus 27 m to the negative 1/3. Again, we have a common factor because we see an m in each term. The smaller of the two exponents is negative 1/3, so I'm going to factor that out. M to the negative 1/3. And what am I left with? M to the 8/3 minus negative 1/3. Now you can come over here, make a little piece of scratch paper. I'm going to do that. 8/3 minus negative 1/3. You can go ahead and do that on scratch paper. So I have that minus a negative. That makes it a plus. So that is 9/3 or 3. So this is m cubed plus 27. Now let's continue. We have the sum of two cubes, and with practice, we don't always have to write this intermediate step. Remember in the previous problem right here, we took time to write the expression as the difference of two cubes with those cubes very obvious. But if you practice, you won't have to take that intermediate step all of the time. So on this problem, I'm going to go straight to the factorization without taking that 27 and writing it as 3 cubed. Hopefully you know it's 3 cubed. So my next line will look like this. Let me get my parentheses set up. And I'll even put the signs in. I have a plus because it's the same sign, and then the opposite sign, and always positive. So I remove the cubes. That's an m cubed, so I just have an m. And I know 27 is really 3 cubed. So if you're going to skip that intermediate step, you still need to be on high alert for what the number is that you are going to write. So we make sure we write the 3. And now I fill in the binomial, or excuse me, the trinomial by using our pattern. The first term squared, so I have an m squared, then the product of 3 and m, and then 3 squared. And we have it factored. One more time, let me remind you that this trinomial right here is prime, so we don't factor it any further when we're factoring with respect to the integers. I want to do one last problem for you. And here it is. 2x to the 4th, 2x to the fourth plus 5x cubed minus 16x minus 40. Now, as always, we look for common factors first. There aren't any. And notice this is a 4-term polynomial. That suggests factoring by grouping. So let's do that. If we group these first two terms together, we see the common factor is x cubed. And then we're left with 2x plus 5. And if we look at these next two terms, we see that the common factor is negative 8. And if we factor out a negative 8 there, we're left with 2x plus 5. You can double check that using your distributive property. But now I can continue factoring by grouping because I have a match. Notice I have a 2x plus 5 and my 2x plus 5. So out comes a 2x plus 5. And then my second factor is x cubed minus 8. But we're not finished because you don't stop until each of your factors are prime. And right here in this problem, our second factor is the difference of two cubes. So we're going to continue. I'm bringing down my 2x plus 5. I, again, chose not to take the intermediate step of writing it as x cubed minus 2 cubed, but you can if it makes you more comfortable to do so. So I have my binomial and my trinomial. I can fill in the signs, same sign, opposite sign, always positive. And for the binomial, I have an x minus 2. And for the trinomial, I'll take my x and square it. In the middle, I'll have 2 times x. And for the last term, I will have 2 squared, which makes 4. Now, each of these factors is prime with respect to the integers. So I wanted you to see this one because sometimes the sum or difference of cubes will come a little bit later in the problem as it did in this case. So you're always going to be looking to see if it's a possibility.